Hey guys, welcome back in. Mr. Marone here. We are now into the second part of Lesson 6.2, which is the trapezoid. It is also a quadrilateral. Everything in Chapter 6 is going to be a quadrilateral from here on out. But a trapezoid has exactly one pair of parallel sides. Okay, so one pair of parallel sides, and they're known as the bases. It's really like the top and the bottom of a trapezoid. Okay, those are parallel sides. And then the two sides that are not parallel are called legs. So we've got our two legs on the side there. Okay, the non-parallel sides. Now, the two angles that share a common base are known as base angles. So like this angle and this angle at the bottom would be considered base angles. Another set of base angles would be this angle and this angle. Okay, those would be our sets of base angles. Now, when we deal with trapezoids, there's two different things we're really going to focus in on. The one thing we're going to focus in on is the idea of an isosceles trapezoid. So an isosceles trapezoid is a trapezoid that has the two legs being congruent. The bases are not congruent, but the legs are congruent, the two sides of my trapezoid. And if that's the case, we have a couple things that come out of it. The first thing that comes out of it is that my diagonals of the trapezoid will be congruent. In other words, BD and AC will have the same measure since we have an isosceles trapezoid. They're always going to be congruent. The diagonals will be congruent. And the second thing is that each pair of base angles will be congruent. Okay, so this angle and this angle will be the same exact measure, and this angle will be the same exact measure. Not to each other. I should change the color. Sorry, guys. But angles B and C will be the same measure there. So you have a lot that you can work with when it comes to an isosceles trapezoid. So here's an example for us. So if they gave us that QRSP, or PQRS, is an isosceles trapezoid, we know right away that P and S are going to have the same angle measure. We also know that Q and R will have the same angle measure. So that tells me right away that angle Q is equal to 135 degrees. Okay, that's my first step there. Second step is I know that the inside of every quadrilateral measures 360 degrees. So if I take 135 and 135, that's 270 degrees. If I do 360 minus that 270, I have 90 degrees. Since P and S are exactly the same thing, we're using kind of the principles of an isosceles triangle, where we're going to take this remaining 90 degrees and split it in half. And that's what's going to give me my measures for P and for S. So angle P is going to equal 45 degrees. Angle S is going to equal 45 degrees. My second example here, they've given us an isosceles trapezoid. Notice they've told us that, so that gives me indications right away that these two sides are the same. My base angles are going to be congruent. And it also tells me that my diagonals will be congruent. So if my diagonals are congruent, they want to know the value of A. Well, they told us that MO was equal to A plus 13, and they told us that NP was equal to 2A minus 1. Since those diagonals are congruent, we can just set these equal to each other. So A plus 13 equals 2A minus 1. And A is going to give us a value of 14. Now, the last thing we're going to look at today is this idea of what's called the trapezoid mid-segment theorem. So a mid-segment is a line that's created when you connect two midpoints. So in this case, X and Y are both midpoints here. They're the midpoint of their side. So X is halfway between A and B. Y is halfway between C and D. So they've marked that right there. And what you get from this relationship are these two pieces of information. First of all three sides are now going to be parallel. So that middle side, that mid-segment, when we connect those two midpoints, is going to be parallel to the top and bottom bases. And the second thing is that its length is going to be half the top base plus the bottom base put together. We can combine those. And you're going to see that in our example here. So it says that Paxton makes trapezoidal handbags for her friends, and she stitches decorative trim along the top, the middle, and the bottom on both sides of the handbag. How much trim does she need for the handbag? So if we think about this, she's going to do this trim on the front and the back. So she's going to need 6 for the top up here. She's going to need 6 for the top on the other side. She's going to need 9 on the bottom and 9 on the back side. And then we have to find this length here. They gave us these 2-inch things. That tells me that this side and this side are the same. This side and this side are the same. So we have a mid segment here. So this length, which we'll call x, is going to be equal to half my top base of 6 plus my bottom base of 9. So x is going to give me half of 15, which is 7.5. So we're going to add that on the front and on the back. So I've got 12 plus 18 plus 15. So I've got 45 inches of trim total. Big key here is that this mid segment, it's the top and bottom bases, not the legs. So bring in any questions you might have tomorrow into class, and we will take a look at them then. Have a great day, guys. Bye-bye.